you confused about electricity? Well, I was too, until I started teaching it, okay? So, listen to me, listen to this video, and I'm going to get you through it, I promise. So, let's start with the basics. We're going to start with Ohm's law, okay? So, Ohm's law tells us that the potential difference across a component, which we can write as V, is directly proportional to the current, okay, which I'm going to write as I. Now, directly proportional means a really special thing. It means that these two guys are going to go up at the same rate. So, if I double the potential difference, the current is going to double. If I halve the potential difference, the current is going to halve. So these guys are going to change at the same rate. Now, I can tell if something is directly proportional on a graph by drawing it, and if I get a straight line that goes through the origin, that means that these variables are directly proportional. So, the next question we need to talk about is what is resistance, okay? So we can think of resistance as being the ratio of the potential difference that an electron has to the current. So it's kind of like how much energy they have versus how fast they are going. Now, I always like to think of this like riding a bike, okay? So we're going to imagine that you're cycling a bicycle uphill, okay? You're putting in lots of energy, but you're not going very fast. So we'd say that this is a high resistance. Now, if you're cycling downhill, on the other hand, you're going very fast and you're not putting in very much energy. So that would be a low resistance. And we say that the resistance and the current are inversely proportional to each other. What that means is that as one thing goes up, the other thing goes down. So if we increase the resistance in a circuit, my current is going to decrease. Or if we decrease the resistance in the circuit, my current will increase. So these guys are going in the opposite direction. Now, if we rearrange this equation here, we're going to get it in the form you get given on your equation sheet, which is V, potential difference, is equal to the current multiplied by the resistance. So this brings us back to Ohm's law again. So the current and the potential difference are directly proportional to each other. So as one thing goes up, the other thing's going to go up at the same rate, providing that the resistance is constant. Things that you're going to meet at GCSE that can change the resistance of a material are going to be things like temperature. So Ohm's law is the potential difference and the current are directly proportional to each other at a constant temperature. So let's have a go at using this equation in some circuits. So hope you've all got your calculators, hope you've all got your formula sheet. Let's start with this circuit here, okay? So I know you've been introduced to this idea that what we've got is we've got like unit charges coming out of the cell and they're carrying little energy drinks, okay? So because the potential difference over the cell here is 3 volts, each unit charge is carrying like 3 little energy drinks, okay? Now the only component, the only obstacle they've got to go through is this resistor here. So they're going to drink all of their energy drinks before they go over this resistor, okay? So that means the potential difference over this resistor is going to be 3 volts. So if I want to work out the resistance of the resistor, I can use this equation. I know the potential difference of the resistor, it's 3. I know the current in the resistor because this is a series circuit, so the current is the same everywhere. Because these little runners that are coming out of the cell, they've only got one way that they can go. They haven't got another way that they can go. They can literally only follow like one path. So the current's going to be 1, and that will give me the resistance. So the resistance will be 3, and we measure resistance in a unit called ohms, okay? We write it as an omega, which is like a Greek O. We don't use like our alphabet O because that looks like a 0. So we spell ohms like that, same as Ohm's law. So that's a nice way of remembering what we measure resistance in because we measure it in ohms. Now, if we have a look at this circuit down here, things are going to get a tiny bit more tricky. So, my unit charges are coming out of my cell with 5 energy drinks, okay? But they've now got 2 obstacles to get through. So they're not going to drink all of their energy drinks just before they go over one obstacle. They're going to share them out. We are told they're going to drink 3 energy drinks when they go over the resistor. So that means they're going to drink the other 2 as they go over the light bulb here. So we can work out the resistance of both of the components. So we can work out the resistance of the resistor. We're going to take the potential difference over the resistor, which is 3, divide it by the current. Now the current's going to be the same everywhere in this circuit because it's a series circuit. So we're going to divide it by 0.5, which will give me an answer of 6 ohms. So the resistance of this resistor here is 6 ohms. I'm going to do the same thing for the bulb now, okay? So I've got my potential difference here of 2 volts, divide it by 0.5, which is the current, to give me an answer of 4 ohms. Now, I can work out the total resistance in this circuit. And there's 2 ways that I can do that. The first way that I can do it is that I can add the resistances of the components together. So I can add the resistance of the bulb to the resistance of the resistor. So it'll be 4 ohms plus 6 ohms will give me 10 ohms. Okay, that's one way that I can do this. Another way that I can do this is I can look at the potential difference over the whole circuit and the current in the whole circuit to find the resistance in the whole circuit. So I'm going to do the V, potential difference over the whole circuit is this one here, it's 5 volts. Divide it by the current in the whole circuit, the current's the same everywhere in this circuit, so that's 0.5. And oh look, that also gives me an answer of 10 ohms. So I can work out the resistance of a series circuit using either of these methods. Now, this guy here, this is a parallel circuit, okay? We know it's a parallel circuit because my electrons are going to have different pathways which they can go down. And we call each pathway a branch, okay? So imagine a bit like a tree where you've got all the pathways coming off, so each pathway is called a branch. Now, you don't need to know how to calculate the total resistance of a parallel circuit. That's an A-level problem, okay? So a couple of you are going to need to stay tuned for another few years. But what you do need to know is that you need to know that the total resistance of this circuit is going to be smaller than the smallest resistor. So it's going to be smaller than the 5 ohm resistor would be my smallest resistor. So it's got to be smaller than the 5 ohms. Okay, so that's all you need to know about parallel circuits. Series, we add the resistances together. Parallel, the total resistance is just going to be smaller than the value of the smallest resistor. Right, final thing that I want to talk to you about then is variable resistors. So there's 3 main types of variable resistor that you need to know about. Now the first one is called a rheostat, and you might have used these guys in lessons in school potentially. So they've got a slider that goes along the top, and what that slider does is it changes the length of a piece of wire. So it changes the resistance. So we can use a rheostat to use a slider to manually, so like I can do it, change the resistance of the resistor. It's really useful when we're doing practical work because we can change the current in a circuit without having to like switch cells out, stuff like that, okay? Sometimes a rheostat is just referred to as a variable resistor, okay? And its circuit symbol is that guy there. Now, a thermistor is something that's slightly different. It's a thermally controlled resistor, or like a resistor that responds to temperature. So, because it's like a thermistor, if you think about the word like thermal, that kind of means temperature, right? So it's a temperature-controlled resistor. And what happens with a thermistor is that as the temperature increases, the resistance decreases. The circuit symbol for a thermistor is a bit like a resistor, that's got a drinking straw going through it. And if we were to draw a graph of temperature versus resistance, your graph looks like that. It's a nice curve like that, because as the temperature increases, the resistance decreases, okay? The final resistor I'm going to talk to you about today is a light-dependent resistor. Now, a bit like the thermistor, it responds to light, okay? So the thermistor responds to temperature. The light-dependent resistor, sometimes called an LDR, responds to light, okay? So we can think of it as being like a light-controlled resistor. So as the light intensity increases, the resistance of your LDR will decrease, okay? And again, if we were to draw this on a graph, it looks just like the graph for the thermistor, except we've got light intensity on the y-axis, resistance on the x-axis, and it looks like that. You need to make sure that you know both of these graphs for your exams. Right, that is resistance. I hope you're feeling a bit more confident about electricity. Stay tuned for more electricity content just like this, and don't forget to subscribe to my channel. I'll see you soon, guys. Bye!